So let's do a problem on this network functions. Okay, so this is how usually the question will be asked. That is, they will give you a circuit and they will ask you find the network functions v1 by i1 or v2 by v1 and v2 by i1. So they'll ask you to find different network functions. Okay, they'll give you a circuit, they'll ask you to find the network functions, and you can use any method you want to find the network functions. Okay, but even though you can use any method, you can either use Kirchhoff's voltage law, that is mesh analysis, or you can use the Kirchhoff's current law or node analysis. You can use any of these methods to find the ratio of all these values, but there are some circuit, there are some techniques that you need to use in order to shorten your time, because time is also an important factor. It's not simply finding the answer, you see, because there are different methods to solve this problem. Okay, there are different methods, but the only disadvantage you're going to have is that you need to find out which method is good to find the answer within the shortest time. Okay, because we are not simply looking, because from the exam point of view there are only 3 hours in this exam, and if these kind of questions will be asked only for 6 marks or 7 marks or maximum 8 marks. So for these kind of questions you are not supposed to spend more than 10 minutes. So if you go for the long cut method, it might take 20 to 25 minutes for you to solve this problem, which you don't have. So therefore, this is where you actually need the practice. Understanding the concept is very easy, but doing the problem will be more of needs some practice for you. So because the more practice you have, then the faster you will be able to write. So here in this video, I'm not only going to do this problem, I will also right now in this first video itself, I'm going to tell you how to write the equations or express the equations in a real fast manner. Okay, because speed is also a criteria you need to attend to when you're doing these kind of problems. Otherwise it will take a lot of time. So like I said, you can use any method you want, but only one of these methods is actually good for doing this problem within the shortest time. Okay, now so let's do this problem. So here, this is the network they have given here. So the first thing you need to do when you see a circuit, right, you should look at how these values are written. These values are all written in real time, right? See, look at the value of the capacitor, it is 1 by 4F. Look at the value of the inductor, it is 1 by 2 Henry. The value of this inductor is also 3 Henry. The value of this capacitor is 2 Faraday. Okay. Also, they have marked the V1 and I1 in the question. The V1 and I1 and V2 and I2. In some questions, they will not mark V1, V2 or I1, I2. They will not mark. They'll just simply give you the question and they'll simply ask you to find these parameters. If that kind of a question ever comes, you should understand that always the V1 is the voltage across the first port, V2 is the voltage across the second port, and I1 is always the current in the first port with the direction into the network. Also, I2 is the current that is in the port 2, which is going into the network. So don't forget the direction of I1, I2. It always flows into the network. Okay, that is for I1, it is from left to right, and from I2 it will be from right to left. So always, this is how direction always goes. Okay, now I think the reason why they have given V1, I1, I2 and V2 in this question is because here they have written that the I2 is equal to 0. They have already said that I2 is equal to 0, which means you don't have to find the value of I2. All you need to do is find the remaining parameters. Okay, so that makes this question much more simpler. So the first thing you need to do is you cannot find network functions, because each of these network functions are actually Laplace transform. So which means first step you need to do is apply Laplace transform to the circuit, or find the transformed impedance of the circuit. Okay. So when you're going to find the transformed impedance, don't worry about the initial conditions or steady state conditions. Those kinds of things are not mentioned over here. So you can simply assume that the initial conditions and all are nothing but 0. Okay. So now let's do this problem. So if I'm going to redraw the circuit, the transform impedance of the circuit, capacitor means, how do you write, what is the Laplace transform of a capacitor? 1 by Cs. What is the Laplace transform of an inductor? It is Ls. Okay, so don't forget that. So therefore, first I will draw the capacitor over here. So here it is 1 by 4F. That is the value of C is 1 by 4F. If I substitute C 1 by 4F, what will I get? I'll get 4 by S. So the impedance of this capacitor is 4 by S. Okay. Likewise, the impedance of this inductor, it should be Ls. What is the value of L? 1 by 2 Henry. So therefore 1 by 2 into S, or it is S by 2. Likewise over here also the impedance is, the value of L is 3, so it will become 3S. So this is 3S. The value of the capacitor should be 1 by CS, and the value of C is equal to 2. This is 2 Faraday, right? So C is equal to 2. So you'll get 1 by 2S, and that's it. Right now I just want all of you to pause writing everything, and I want you all to see how I'm going to write each and every equations, okay? Because different textbooks has different ways of writing. You see, likewise, if you see over here, okay, this is V1 and I1, V2 and I2. So you need to find the equations of each of these network functions, okay? So the problem is that the main theme that we apply here is substitution. You'll be finding an equation of some parameter which you don't want. You don't want that parameter in the equation. So how do you remove that parameter from the equation? You substitute that parameter with another equation and you solve it, okay? So I will tell you how it is being substituted. I think most of you already know how to do the substitution, but the problem is, one thing I'm telling you that substituting an individual term is far worse than substituting as a group. It is always better that you substitute this term as a group, so that then the equations will become more easier for you. Okay, let's do this problem. I'm talking too much. Let's do this problem, then I'll show you how to do this. So the first thing over here is, this is I1. Okay, this is I2, this is V2. So the first thing what I'm going to do is, I'm going to start from right to left. Okay, I'm going to access this equation from right to left. Okay, so which analysis is better, Kirchhoff's current law or Kirchhoff's voltage law? Is it node analysis or mesh analysis? That is one thing also you need to understand. If you see a ladder circuit like this, or parallel circuit like this, if you see a ladder circuit like this, it is always good to apply Kirchhoff's current law. Okay, it is always good, it is always better and less time consuming if you apply Kirchhoff's current law to this circuit. Kirchhoff's current law, that is much more easier than applying mesh analysis. There is node analysis in this kind of circuit. If you see a ladder circuit, a ladder shaped circuit, if you see it anywhere, it is always good to apply the node analysis. Okay, so I'm going to apply node analysis over here. So how to know? So to apply node analysis means I need to name the node of these two. I need to mark the name of these two nodes. Okay, so what is the name of this node? The name of this node is V2, right? The name of this node is V2. Why it is V2? Because you see over here, this is a single connection. There is no resistor or capacitor or inductor or anything between these two. So therefore, if this is V2, the same voltage is across this entire connection. So therefore, this is also V2. Okay, so this is V2. And what about this point? Well, this point is V1, but this is not V1. Why? Because there is a capacitor in between them. So there is a difference in voltage. So this is not V1. So you have to give another name to this. So that name I'm going to give is VA. Okay, I'm going to give the name as VA. So now I'm going to apply the node analysis, and applying the node analysis always should be done. The shortest way of doing it is starting from right and move towards left. So that means first I'll write the node analysis of this, then I'll write the node analysis of this, then I will try to find the equations, corresponding functions. So first I'll apply node analysis over here. Okay, so here it is V2, right? So the equation will be that is applying KCL at node V2. Okay, so what do you get? This is V2. Why it is V2 is because this is entire connection is V2. There is no any obstacle between them. That is why this is V2. So the equation is V2 by V2 minus 0 by 1 by 2s plus V2 minus VA by 3s is equal to 0. Okay, so what this means is that I can reduce this equation. This will become 2s V2 plus V2 minus VA by 3s is equal to 0. Okay, or in other words, v2 minus va by 3s is equal to minus 2s v2. Okay, or in other words, I can say that va minus v2 by 3s is equal to 2s v2. Okay, see what I'm going to do here is, like I said before, we are trying to find only these network functions. So which is the unwanted parameter that is going to come into our equation? This is the unwanted parameter. We don't need to find va in our equation, so we need to remove va. So what I'm going to do is I'm going to find the equation for va, which I can substitute in the coming equations. So here it is. What's the equation for va? Here va is equal to how is it written? Va is equal to 6s square v2 plus v2. Okay, this is the equation for va, or you can say va is equal to v2 into 6s square plus 1. This is the equation for va. Okay, so this is one equation of EA. So now if I see VA anywhere, I can substitute that VA with this equation. Okay, so next I'm going to apply the KCL, or I'm going to apply the Kirchhoff's current law to this node VA. So applying KCL at node VA. So what do you get? So here the equation over here is, first we'll start with this, that is, this is VA minus V1 by 4s by 4 by s, right? Or it's a writing that already there's a that branch already has a name, it's called as I1. So this is minus I1 plus, I hope all of you remember why it is minus I1, because this current is incoming, not outgoing. Only outgoing current will mark it as positive, and incoming currents are marked as negative. That's why it is minus I1. Okay, minus I1 plus, what's the current through this branch? It is VA minus 0 by s by 2, or VA by s by 2. Okay, plus, now this is where I want to tell you about the technique what I have said earlier. That is, see, let me use another pen. Plus, what is the remaining current? It is VA minus V2 by 3s. VA minus V2 by 3s. I will tell you why I am using different pen for this. Okay, and this is equal to 0. Okay, so basically what you are trying to do is, you are going, that's why you're basically what you're going to do is you're using these network functions. You're trying to find these network functions. So the only way by doing this is by substitution. That is, you have already found the equation for VA, so you're going to substitute the equation VA in this equation, and then you're going to solve it. Okay, but right now itself I'm going to tell you another trick. That's what I said earlier. It is better to substitute as a group than to substitute as an individual. For example, okay, here in this equation, you don't want VA. You're trying to find, what is the equation you're trying to find from here? What equation you can find? You can find the equation of this, right? You can find V2 by I1 from here. Very easy. But the only thing you don't want is VA. So since you don't want VA, what you're going to do, you're going to substitute the equation of VA from here. That is, VA is equal to V2 into 6s square plus 1. You're going to substitute this equation over here. And that is how you are going to solve it. That is how usually all students will solve it. But the thing about this method is that it is a very time consuming process. That is why I am telling you it is better to substitute as a group than to substitute as an individual. For example, if you look over here, VA minus V2 by 3s, the same term is already over here also. See, here it is. VA minus V2 by 3s. What is written over here? V2 minus VA by 3s. We are talking about this branch. This branch we are using this branch to write the equation for this node as well as the equation for this node. For both these nodes, we are writing this is the common branch that you are writing. That's why the same branch is over here and over here. So since you already know the equation of this term, all you need to do is substitute this equation over here. Okay, that's all you need to do. And this VA, you can use it to substitute this equation. VA is equal to V2 into 6s square plus 1. That is the trick that I'm trying to tell you. That is, this is the shortest way of solving. That is, wherever you see a group term like this, it's always better to substitute it as a group. Okay, because remember that whatever substitution you are doing, you should substitute it in such a way that the equation becomes more simpler, not longer. Okay, try to make it more smaller. Try to make the substitution in such a way that the equation becomes more smaller, not greater. Then only it will be very easy for you to find the network function. Otherwise, it will be a very time consuming process. Okay, so here what I'm going to do is, this is minus I1 plus, now equation for, what is the equation for VA? I'm going to use this equation, that is V2 into 6s square plus 1. So this is, s by 2 can be written as 2 by s, right? So this is 2 into, and what is VA? VA is V2 into 6s square plus 1. Okay, 6s square plus 1 by s. Plus, now this term, like I said, I am not going to substitute the VA of this equation over here. Rather, I'm going to use this equation because this is much more simpler. That's why always try to make the substitution as a group. Make a group substitution is always better than an individual substitution. If you don't have a common group, then only you can go for the individual term substitution. But this is a group substitution because that will make the equation more simpler. So V2, so here you need is VA minus V2 by 3s. Here it is V2 minus VA by 3s. So if you want VA minus V2 by 3s, all you need to do is put a negative sign in front of it. So minus of minus is plus, so it is nothing but 2s V2. So this is nothing but 2s V2, okay, equal to 0. See, this is the technique I'm trying to see. So now you can find, so see, now this equation has only V2 and I1. This entire equation has only V2 and I1. So definitely you can find this ratio, V2 by I1. So I'm going to find that, V2 by I1. So to find that, I'm going to put I1 over here. Now the rest of the term you can use any way you method, okay, any way you want. So this is V2 into 12s square plus 2 by s plus 2s V2 is equal to I1, and then this, now this is nothing but taking V2 common, this will become 12s square plus 2 by s plus 2s is equal to I1. So therefore this can be written as V2 into, and this is this will become, taking the LCM, this will become 12s square plus 2 plus 2s square by s is equal to I1, and here 12s square plus 2s square is 14s square, so it will become 14s square plus 2 by s is equal to I1, and you are trying to find the equation of V2 by I1, so it is V2 by I1 is equal to, this comes over here s, and this comes on top bottom, so it becomes 14s square plus 2. So this is the equation of V2 by I1. See, this is how you are trying to find it. Try to find it with the shorter steps, with few steps. Otherwise what happens, if you put VA over here, then it will take the entire page and the next page also to find the ratio. So see, what I did is I made a group substitution. Okay, so that will shorten the time to find the network function. Next, so I found V2 by I1. Next, what are you trying to find? I'm trying to find, let me see. So what I'm going to do is, now I'll apply the known analysis over here. What is I1? I'll write the equation for I1, right? What is the equation for I1? The equation for I1 is in this direction from left to right. So this is the higher potential, this is the lower potential. So this is V1 minus VA by 4 by s. This can also be written as s V1 minus s VA by 4. Okay, so like I said, I don't want VA, right? I don't want VA. So what I will do, I will put VA, this equation, I'll substitute this VA over here. So this will become I1 is equal to s by 4 V1 minus s by 4, and what is V2? V2 is this one, V2 into 6 s square plus 1. Okay, this can also be written as, I can put this 4 over here, so this becomes 4i1 is equal to SV1 minus V2 into, and what is V2 is 6s cube plus s. Okay, the problem with this equation is that this equation has all the three terms, I1, V1, V2. I need to remove one of them. Okay, which one? I think I'll remove I1 from here. Okay, I will remove I1. Then so if I remove I1, I can find the value of V2 by V1. Okay, so I'll do that. So I have to. So if you want me to remove I1, I can use this equation to remove I1. Why I'm using this equation is because this equation has V2 and V2 is already over here. So therefore 4 into, what is the equation for I1? From here you can write what the equation for I1. It is V2 into 14s square plus 2 by s, right? That is the equation for I1 is equal to SV1 minus V2 into 6s cube plus s. Or this can also be written as V2 into, I'm going to put this 4 inside this, so this will become 14 into 4 is 56, so it will become 56s square plus 8, right? 56s square plus 8 by s. Okay, is equal to SV1 minus V2 into 6s square plus s. So therefore V2 is nothing but 56s square plus 8 by s plus 6s square plus s is equal to SV1. Okay, this can also be written as V2 into 56s square plus 8 plus, this is 6s cube plus s square, this after taking the LCM, by s equal to SV1. Or in other words, V2 into, this is 56s, here if you add anything, 56s square plus s square is 57s square, 6s cube plus 57s square plus 8 by s is equal to SV1. Or in other words, you are trying to find the equation of what? V2 by V1, right? So you are trying to find V2 by V1. So V2 by V1 is equal to, this will come over here, so this will become s square and this will go down, so this is 6s cube plus 57s square plus 8. This is the equation of V2 by V1. See, so like that, just like how I found V2 by I1, now I found V2 by V1. Okay, now I need to find the equation of what? V1 by I1. Now I'm trying to find the equation of V1 by I1. Okay, so see, if you want to find the equation of V1 by, usually if they give these three terms, okay, all you need to, if they ask you to find three terms, right, just simply look at the terms. Definitely you need to find only two of these terms. Even if they are asked three terms, you just need to find only two of these terms, because you can find the third term from the other two terms. That is why you can find the third term. You can find one of the term from the other two terms. That is, here it is V1 by I1, right? You are trying to find V1 by I1. What is V1 by I1? Is nothing but V1 by V2 into what's the other equation you found? It was V2 by I1. V2 by I1. See. So in order to find the last term, all you need to do is find the other two terms and substitute that over here. So here it is V1 by V2. We already found what is V2 by V1, right? So V1 by V2 is the reciprocal of this, which is 6s cube plus 57s square plus 8 by s square. Okay, this is V1 by V2 into what? V2 by I1. What is V2 by I1? I found out that it is nothing but s by 14s square plus 2. 14s square plus 2. Okay, this is v1 by I1. So s and this s square will cancel each other, so you will get 6s cube plus 57s square plus 8 by 14s cube plus 2s. This is v1 by I1. See, this is how we need to find the answer. Okay, remember these are the different techniques. Okay, first of all, I am using Kirchhoff's current law. I am using node analysis because this is a ladder circuit, or if you see a ladder circuit or a parallel circuit, always go for the node analysis. Node analysis will be much more lesser time consuming than mesh analysis. Okay, mesh analysis, it will take longer time. Then you have to write the terms of current for each of these equations. It will take a lot of time. So node analysis is always better. Okay, for ladder circuits like these. And also another thing is that try to substitute the equation as a group if it is possible. Wherever it is possible, try to make the substitution as a group, because group substitution is always better than individual substitution. Because some individual substitutions are actually very dangerous also, because it is you might be prone to making mistakes. The more complex the problem becomes, the more likely you will make mistakes. So what you are supposed to do is try to make the substitution such a way that the equation becomes more smaller and smaller, not larger. That is why instead of substituting the value of VA over here, I substitute this entire term as a single group. Okay, that's why I didn't take that much time to solve this. And here I can't do anything, so what I will do, I'll substitute that the equation of that individual term. So therefore from here I have got the equation for V2 by I1, and likewise I got the equation for V2 by V1. And then to find the third term, simply use the other two previous terms. We can always find the last term from the first two terms. This is how the basic procedure is. Okay, but like I'm saying again, you don't have to do exactly like this. You can follow your own practice, your own step, but I'm just simply doing this step just to show you that this is actually lesser time consuming. Okay.